This lecture talks about fingerprints and what they are, how they form, how we collect them. And what you see in front of you right here is what's called a 10 card. And if you ever have to be fingerprinted, this is how fingerprints were normally kept on record. To talk about the history of fingerprints a little bit, from 1792 to 1750 BC, fingerprints were actually pressed into clay, typically the thumbprint, to work as an identifier for authors of artistic work or tablets of, that contain documents in ancient Babylon. 1684, Dr. Nehemiah describes the different patterns in fingerprints. And 1788, Johann Mayer noted that the patterns were never duplicated in two people. Even identical twins had different fingerprint patterns. In 1823, Perkin described 9 fingerprint patterns. In 1856, Herschel began collecting fingerprints. 1883, Bertillon, who should sound familiar because he came up with anthropometry, which was the system of body measurements, he created a way to actually identify criminals using their fingerprints by using a repeat offender. It was able to convict him based on those. In 1888, Galton and Sir Henry developed a classification system for these fingerprints, and in 1891, Vucetich improved the fingerprint collection methods, and that's actually more of what we use today in the United States. In 1896, Sir Henry created a system to divide the fingerprints into groups, and in order to do that, he created the 10 card, which I showed you on the title slide. So what are fingerprints exactly? They're ridges that are found on the fingers, toes, the palms, and the soles of your feet. The connected units of the ridges are called friction or dermal ridges. So those are what's going to cause the different patterns that we're going to identify. And the ridges actually have a purpose to help us keep our grip on different objects. And natural secretions, such as sweat, plus dirt on those surfaces leave behind an impression, which we call a print on those objects that we come in contact with. So how do they form? An animal's skin consists of an inner dermis and an outer epidermis. Remember that dermis is the living layer and the epidermis is the thin outer layer. Well, the creation of fingerprints occurs in a special layer, which is called the basal layer in the epidermis. So the epidermis is the upper thin layer, and that basal layer where new skin cells are produced, which would become part of the dermis. Fingerprints probably begin forming at the start of the 10th week of pregnancy. So this is happening to the fetus. And what happens, because the basal layer is growing faster than the others, it's going to collapse on itself, forming these intricate shapes. So that's why they're never the same in two people, even identical twins. And then there's 3 general fingerprint distinctions. We have the arch, which you can see comes in from one side, goes up, then comes out the other side, and that takes up about 5% of the population. The whorl, which kind of looks like a target, it's circular, and that's about 30% of the population. And then the loop is the most common fingerprint pattern that we're going to find. And there's differentiations on all these, but the loop, if you look at it, it comes in from one side, goes up and around, and goes out the same side that it came in on. And that's about 65% of the population. So there's different characteristics. And if you are a fingerprint examiner, you're going to look for the presence of a core, which would be the center of a whorl or a loop. You won't find them in an arch. And in this diagram, you can see, okay, this would be the core. This is the centermost part of this loop pattern we have here. And they're going to look for deltas, which are triangular regions near a loop. So here's the loop. And if you look where this red line is, you see kind of a triangular shape. That's a delta. And then they'll do a ridge count, which is another characteristic to define fingerprints. And the count is made from the center of the core. So they'll take the core and they'll actually count all the ridges to the outside edge of the delta. So they're going to, for this red line, they're going to count from the core, they're going to count all the ridge patterns to the delta. And then we divide those characteristic patterns even more. So arch patterns can be plain or tented. So a plain arch is what I showed you, or a tented arch has a really high peak. And that's kind of rare. And whorl patterns can either be a central pocket whorl, a double loop, or an accidental. And the accidentals are quite rare. The main patterns that you need to know are loop, whorl, and arch. And we've already talked about twins having unique fingerprints, and these small differences that cause that they're called minutia. So the delta that I showed you before, there's eyes and hooks and all sorts of patterns, and those are called minutia that form in the ridge patterns. Now, there's 3 types of prints that investigators look for at a crime scene. Patent fingerprints are visible, that are transferred onto smooth surfaces by blood or other liquids. These are easy to see. So if somebody, had put a bloody fingerprint on a chair or a table, that would be a patent print. A plastic fingerprint is an indentation left in something that's soft, like a clay, a wax, even a bar of soap. And then latent fingerprints are the ones that are a little bit more fun to find because they're not visible, but they're made so by dusting. So in the crime shows, when you see them dusting with all the powders, they're looking for latent or hidden fingerprints. Now, some facts about fingerprints and forensics. Can they be erased? Nope. They can be removed with chemicals, but eventually they'll grow back. Is fingerprint identification reliable? It is, but because the analysts are human, they can make mistakes. And even though we use digital systems now to identify fingerprints, they are still gone over a second time by an analyst. Is fingerprint matching carried out by computers in a matter of seconds, as they show you in the crime shows? No, but APHIS is able to provide a match in about 2 hours for the prints in its master file. If the prints are not in the master file, then it may not come up with a match, or they have to go through other files. So in the smaller areas, so if it's just a local agency looking for a match in their program, it could take much longer if they ever find one because they're limited to the scope of the prints that are actually in their database. They might not have access to the FBI's database. Okay, so now there's different ways to collect latent prints. And the first thing that we always do when we look at a fingerprint is to photograph it. So we're going to photograph it, and then we're going to use some sort of method to make the print visible, okay, or what we say, develop the print. If we're trying to develop a print on paper, we're going to use a chemical called ninhydrin. And when ninhydrin finds a print, it's actually going to turn it to a purple-blue color. Cyanoacrylate vapor is actually superglue. This is called superglue fuming. And you heat it and it produces a white print that's actually kind of permanent. So anytime we develop these though, again, you're going to take a picture before you do it and then a picture after it. And these we're going to leave right on the surface. We could use silver nitrate on substances such as styrofoam or wood, things that are porous, and it's going to turn a black or reddish brown after we look at it under UV light. And then iodine fuming. Similar to the superglue fuming, but we're going to use iodine, and you'd use it for paper, cardboard, or unpainted surfaces, and it turns brown. But the problem with iodine fuming is that it fades very quickly, so you have to make sure that you photograph it quickly. And then if all these we would leave on the surface. If we were using a powder, a magnetic powder or a dust to dust for the prints, then we would actually tape lift it. And what they're showing you in this picture up here is just that. You would put a piece of tape over the surface of the print after photographing it, and then you would smooth that down and then lift it up with the tape so you can take it with you. And that's what's going to occur on surfaces that are too large to take back to the lab. If it's small enough to take to the lab, you would. Now, fingerprinting has come a long way. Now they're using scanning technologies to digitally input them into the computer systems. And what they're using, you're not going to see an actual print, but they come up with identification points. So that's something new that's been around, but it's becoming more and more popular. And then they're using other physical features such as eyes and facial patterns to identify somebody and see if they're as unique as fingerprint patterns. So you can actually take impressions from lips or cheeks, or we don't use palm prints as often, but we can, and all of those are going to be good to identify somebody with. And it's always important to remember that when you come upon a print, that you take a picture of it and then you develop it in whichever manner you need, depending on what the surface is like, and then you're going to take a picture of it again and then lift it if you have to, or take it with you back to the lab to study.